Hello. Oh, hiya, Bill. What's up?
How about John and me picking you up and giving you a ride to work this morning? I'm bringing in my neighbor's car. I think he may have a case of tire thumping.
You think it's tire thump, huh? You sure there's no boot in the tire?
I asked him about that. He said the tires are all practically new, Fred.
Mm-hmm. Well, we'll check the car on that stretch of smooth blacktop near the dealership.
What would cause tire thumping, Fred?
Well, John, it could be caused by a tire not being true in circumference. Or the tire may be perfectly true.
Whoa, wait a minute. That sounds like double talk to me.
Not at all, John. I'm just telling you that it's hard to point to any single condition and say that it's the cause of tire thumping. In fact, it may take several different checks to track it down. You must remember that car suspensions have been improved a good deal in recent years. Cars are made to operate quieter. Tires made to carry lower pressures. All of these improvements make any unusual noises more noticeable than formerly. Sometimes a very slight irregularity in the circumference of a tire will produce a noticeable bumping noise. Anything as small as a penny, for instance, can produce a thump.
I suppose the old spring leaf and hammer method of changing a tire could bend the rim or damage the tire enough to cause the tire to be distorted when mounted.
Certainly could, John.
Just how much thumping can we consider acceptable, Fred?
Well, if the thump is slight and difficult to make show up, it can be considered commercially acceptable and will not affect the life of the tire, Bill. We should explain this to our customers. And explain, too, that the thump is usually heard only on blacktop roads. We should emphasize to the customer the importance of rotating the tires every 2,500 miles. That prevents uneven tire wear and gives him longer service from his tires. Well, here we are on the smooth blacktop road. Now, you hold that speed constant at various stages between 15 and 45 miles per hour, Bill.
There it is. I feel it now.
Uh-huh. Yeah, I feel it now myself. Now, suppose we drive into the service department and I'll help you run it down.
Well, so you guys decided to come to work after all. I've been waiting for you.
Oh, hiya, Tech. We're going to track down the tire thump in this car. You want to give us a hand?
I sure do. Lead on, my boy.
Suppose we start out by making a test that'll help us pin down which tire is thumping, or if thump is caused by something other than tires.
Well, that's the inflation test, right, Fred?
Right you are, Tech. First, we inflate all tires to 50 pounds pressure, and we drive over that stretch of blacktop again. Now, if the thump is still there with the tires inflated to 50 pounds, we'll have to start looking for some cause other than tires. Now, let's go out and make our test. Well, here we are back again. Let's go over what we did. First, we drove the car over that blacktop road, and Bill said the thump was gone. That confirmed what we already suspected, that the thump was in one of the tires. Then we kept inflating and deflating the tires until each tire had been driven at 27 pounds pressure, while the others were inflated to 50 pounds.
Right. And we found that the left front tire was the one causing the thump. Now what do we do?
Now we'll try switching this left front tire with a right rear one to change its direction of rotation. Sometimes changing a tire's direction of rotation will stop a thump. This is another reason for periodic tire rotation.
Suppose switching the tires didn't correct the thumping.
Well, that means we'll have to check the tire and wheel which had the thump for radial runout. Now, here's how you do that. First, we jack the wheel off the floor and coat the tread with a soap solution so the anvil of the dial indicator will have a smooth surface to bear against. Then we mount the dial indicator on a substantial surface so that there will be no deflection. Then, with the anvil of the indicator against one of the center ribs of the tire tread, we rotate the wheel slowly, marking any point that shows a variation of more than 50 thousandths from the starting point reading. If a variation in reading of more than 50 thousandths of an inch is found at any one of these points, that is no more than 10 inches from the next mark on the circumference of the tire has too much radial runout and should be replaced.
But remember, this 50 thousandths runout is for a 10-inch travel of the wheel. There can be a total runout up to 80 thousandths for the whole circumference without affecting the performance or life of the tire.
Right, Tech. But no more than 50 thousandths runout for any one 10-inch space.
How can you be sure whether any abrupt runout variation is due to the tire or to the wheel, Fred?
That's a good question, John. Here's the way we find out. We shift the dial indicator from the tire to the base of the rim flange without removing the tire from the wheel. If the same variation is found in the wheel at the same spot as on the tire, it can be assumed that the wheel rather than the tire is at fault.
There's another important point to remember when checking runout. The part of the tire which was on the floor just prior to jacking up the wheel may be flattened.
Flattened? How come?
From the weight of the car, Bill. You see, if the car has been resting in one spot for as little as 1 minute, the rubber in that area of the tire tread will become flattened.
It sure will. So don't let this flat spot fool you when checking the tire for runout.
Now, in some cases, that particular spot may register as much as 30 thousandths less than the area on either side of it.
Well, that spot will fill out again, won't it?
Oh, sure it will, after the car has been driven far enough to get the tire warm. Now, when the tire is warm, that spot will be equal in measurement to the area on either side of it.
Now, what if we're convinced the thump is actually caused by the tire, Fred? Our car warranty doesn't include tires.
That's right, John. But it would certainly be to our advantage to handle the replacement negotiations for the owner with the tire dealer. You know, we want our customers to know that we have a reputation for giving complete service of the product we sell.
Well, you've got a point there, Fred. Say, are there any other conditions that could cause this tire thump?
Well, there are some mechanical conditions that may combine to cause a noise that sounds like tire thumping, John. For example, you might find that the brake drum bolt circle was eccentric in relation to the center line of the axle.
Or the wheel retaining bolt circle could be eccentric in relation to the wheel rim.
Right, Tech. Or you may have stiff or frozen shocks.
Now, what about uneven tire wear, Fred?
That may do it, too. And you may have to check the tires for breaks in the casing, boots in the tire, or for an incorrect tube. And you may find that the bead of the tire is not properly seated in the rim, or the rim may be bent. Now, that sounds like a lot of points to check. But we want to track down all possible causes of tire thumping.
That was a good story on tire thumping, Fred. Now, I've got another question. What's the story on high-speed car shake?
Now, that is a good question, too, John. There are many angles to that condition, and now's a good time to talk about them.
Right you are, Fred. But somebody better shake a leg and turn this record over so we can get going.
Let's start out by defining car shake. Actually, it's a lateral movement of the windshield pillars, the steering column, floorboard, and other components of the passenger compartment.
Another place where a shake would be noticeable is in the front seat frame.
Right, Tech. The bolts which attach the seat frame to the seat guides, as well as the bolts which attach the guides to the floor, should be checked to make sure they're tight. If the seat frame tends to vibrate, the owner might be confused and think that the vibration was present throughout the car. In some cases, merely tightening these bolts will eliminate a condition which at first check appeared to be a pretty bad case of high-speed car shake.
And don't forget about improperly fitted doors or loose door glass and loosely mounted rearview mirrors. They'll all give you the impression that the whole car is shaking.
That's a good point, Tech. Make sure they're tight and ship-shape.
If you've really got a case of car shake, the windshield posts, the steering column, and even the floor of the car will shake from side to side.
That's about it, Tech.
Is there any way of knowing whether the front or the rear wheels are causing the shake?
Very often you can tell whether the front or rear wheels are the culprits by the speed at which the shake occurs, John. If the shake starts at about 50 miles per hour, it's usually associated with the front wheels. If the shake doesn't come in until about 75, it's usually caused by the rear wheels.
And sometimes you might have both. The condition may start as you pass 50 or 55, and when you reach 75, it may become worse, indicating that the front and the rear wheels are out of balance.
That's right, Tech. And you'll probably find that the major causes of high-speed car shake are radial runout of the tire and wheel as an assembly, or an unbalanced tire and wheel assembly.
But the assembly does not necessarily have to show radial runout in order to be out of balance.
Right, Tech. Now remember, at this point, we're checking for causes of car shake, not tire thumping.
And in tracking down a case of high-speed car shake, the first point to check is for eccentricity or runout of the tire and wheel as an assembly.
And this check is made just the same way we check for a high spot on the tire. You'll remember that we placed a dial indicator against the center tread and rotated the wheel slowly, noting the maximum runout. You remember, too, that we said a total runout up to 80 thousandths of an inch would not be sufficient cause for replacing a tire that was thumping. The same is true in the case of car shake. But since a runout of this much would have a tendency to unbalance the assembly, it is advisable to reduce the runout to not more than 60 thousandths of an inch.
And if you find a runout greater than 60 thousandths, you can be satisfied that it's a contributing factor to the shake condition. Maybe not the main factor, but an important one.
What about the position of the wheel on the brake drum, Fred? Could that be a cause of excessive runout?
Yes, John, it could. Now, here's how we make that check. We shift the wheel on its mounting on the brake drum. There is a bare possibility that the bolt holes in the drum may not be concentric with the spindle, or the bolt hole circle in the wheel may not be concentric with the rim. Shifting the wheel on the drum may compensate for these conditions. You'll have to try the wheel in different positions on the drum and select the position that gives the least amount of runout.
And if this doesn't do the trick, remove the tire and shift it 180 degrees on the wheel. Of course, this may make it necessary to rebalance the wheel assembly. Shifting the tire may have upset the balance.
Suppose that doesn't do the trick. What do we do then?
Then we'll have to dismount the tire and check the wheel for runout. We do this by placing the dial indicator anvil against the inner tire bead surface of the wheel and rotate the wheel slowly as we read the total runout. Then we move the dial indicator anvil against the outer tire bead surface and check the wheel again in the same manner. Total runout of the wheel must not exceed 45 thousandths of an inch in either case. If it does, the wheel will have to be replaced.
What about a balance check, Fred?
A balance check is important, John. But if we were not able to get the total runout within the 60 thousandths limit for the tire and wheel as an assembly by the methods we've just talked about, the wheel or tire will have to be replaced. However, if we were able to get within the proper runout limits, our next step would be a check for proper balance of the tire and wheel as an assembly at high speed. We check the front wheels for balance by placing a jack under the center of the front of the car and raising both front wheels off the floor so the wheels hang down on the control arms. Then we place a wheel spinner against the tire and spin the wheel up to high speed.
And if that wheel is out of balance, it'll jump up and down like a bug on a hot griddle.
It sure will, Tech. Now, if the wheel is in balance, you should be able to place this crumpled towel or your handkerchief on the fender just above the wheel you're checking and have no vibration of the towel or handkerchief at any speed of the wheel.
And you better inspect any wheel you're checking for balance to see if there's mud or tar caked on it. This could throw the whole wheel assembly out of balance.
That's a good point, Tech.
And if you find that the wheel is out of balance, I suppose you remove it from the car and mount it on a wheel balancing machine to find how much weight is needed and where it should be placed.
That's one method, John. Some shops have another type of wheel balancing machine, John. And the balance is checked with a wheel on the car, merely by clamping the balancing mechanism to the wheel assembly. When the size and location of the weights needed to balance the wheel is determined, the amount should be divided so that half of the weight can be attached to the inner rim of the wheel and half to the outer rim.
What about the rear wheels, Fred?
We check the balance of the rear wheels by placing a jack under the frame side rail at a point 12 inches forward of the rear spring front hanger and raise one rear wheel off the floor. Then, with the engine running and the transmission shifted into direct drive, spin the wheel through the various speed ranges, 20, 30, and 40 miles per hour.
And don't ever exceed 40 miles per hour on the speedometer. And remember, with the opposite wheel on the ground, the spinning wheel will revolve at a speed equal to twice the indicated speedometer speed.
That's a good point, Tech. 40 miles per hour, for example, is equal to 80 at the wheel. Again, we use the crumpled up towel or handkerchief to check the balance. If there are no vibrations of the folds, the balance is okay. If you find that the wheel is out of balance, add balance weights to it just as we did to the front wheel.
Is it ever necessary to balance the brake drums by themselves?
Once in a while, Bill, when you don't seem to be able to do a perfect job of eliminating all the vibration by just balancing the wheel. The reference book has a story on drum balancing. Hey, Tech, you leaving us?
Yep. I got to call on some more of the boys, but I'll be around again next month. You did a good job telling John and Bill about tire thumping and car shake, Fred. And let me say this. Show an interest in your customers' problems and do your best to correct them, and you'll have happy, satisfied customers. So long.
So long, Tech. See you next month.